Historically, the SOC design has consisted of two separate or distinct phases. One is the front end, which is the RTL synthesis, optimization, and verification, and the second is the back end, which is the physical implementation. However, because of the latest technology nodes, there's a lot of coupling between the two, and you cannot actually separate the two. You cannot do them separately. One has to consider the impact from the other, and the decisions that are made during RTL synthesis or optimization actually are very large, and their impact on the backend or the physical implementation. So one thing what could happen is the loss of predictability. So what by that I mean that if the front-end designer, the RTL designer, does not, he closes the design, it meets the timing and the area. However, when it goes, he throws the design over the wall to the backend designer, and the backend designer does its job, then suddenly it doesn't meet the timing anymore, or it takes more area, simply because there is a lot of effects which are coming in the backend which were not taken into account during the front end. So the front-end designer needs to have a good confidence that whatever he did will be able to actually meet the target once the backend does its job. Our RTL synthesis tool, the RTL optimizations, several of the key optimizations are what I call physically aware. That means they take into account, they work very closely with the physical implementation capabilities or optimizations. And for example, they would use the same engines, the RTL optimizations, the physical optimizations, and the physical implementation tool, which is the backend. As a result, there is a very good correlation in the timing picture that the RTL synthesis sees, and also the area. So as a result, we are able to close the design much faster in the backend. Also, we can read in a floor plan, and we have a very powerful timing-aware macro placement engine that the RTL tool reads, which actually addresses all the critical paths that actually go through these macros, for example, memories. So we are able to optimize these paths much better during RTL synthesis itself. So that is, we have a strong solution for predictability. For congestion, we have, in our latest release, we have a very good congestion optimization, which basically comes up with right structures, RTL structures and architectures, which will lead to less congestion, or the congestion hotspots that I talked about. So, and actually in a recent competitive benchmark against one of our leading synthesis competitors, Talus Design, which is our RTL synthesis product, resulted in much fewer congestion hotspots and about 1/3 leakage power, meeting the same frequency or the timing target. So that is our very good solution for congestion optimization.